Hey guys, in response to a number of queries I've had from you guys about financial maths, I said that I'd maybe just put together a little masterclass on this topic. So what I'm going to do with you here is I'm going to take you through all of financial maths in one go. Just do it all together in one little class here. It doesn't matter if you haven't covered financial maths in class yourself yet. There's very little theory here that we need to get right. I'll show you how to do it. And really, it's just an extension of something that you will be learning, or you may already have learned in sequences series. So essentially, the main body of financial maths for higher level Leaving Cert is an application of geometric sequences and series. So essentially, you've got a series of repayments on a loan or a series of deposits into a savings account that form a geometric series, which we can then just add up using a formula from your formula booklet. Now, as if you haven't done geometric series, don't worry about that. I'll show you what you need to know here. But fundamentally, that's what I need to know for financial maths. All right? There's a little bit of kind of junior cert financial maths that is technically on the Leaving Cert course as well. It's more a part of the ordinary level course. So working with kind of income tax, PRSI, USC, things like that. That's technically on the Leaving Cert higher level maths course as well. There was a question in 2024. Just a small part, like 10-mark part of a question that did ask you to calculate some income tax, all right? So I'll just remind you of that very quickly at the end. But the main thing to be focusing on here is seeing financial maths as an application of geometric sequences series, right? So the notes that I've provided with here, I'm going to go through a few questions with you that kind of show you everything you need to be able to do in financial maths. I've then included on the notes all of the past exam questions on financial maths, along with full solutions for them. And then at the end, just as kind of a bonus, there's a few practice questions. Exam style questions of financial maths, you can have a go at yourself. And if you can kind of do those sample questions at the end, you can be fairly confident you've got your head around the bones of financial maths. Okay, so we'll get stuck in here, and I will be on the chat as we go along. So if you have any questions at any stage, feel free to pop into the chat and drop it in there and ask me. You can answer the question as we go along through the class. Otherwise, if you want to hang around to the end and ask a question afterwards, you can do that as well. But I will be on the chat through the entire session here. So feel free, as I said, if you have any questions as we go along, to pop them into the chat, and I'll answer them for you as we go along. Okay? So essentially, financial maths, it's a story of 4 formulas. Okay, so there's 4 formulas we're going to be working with here. So first of all, in your formula booklet on page 30, so you can see that's the financial maths page. Okay, so page 30. And it's these 2 formulas here. The F equals the future value formula. F equals P times 1 plus I to the power of T. And then the present value formula. P equals F over 1 plus I to the power of T. Now, if you look at those 2 functions, that's slightly unusual, or those 2 formulas, that's slightly unusual for your formula booklet, because that's the same function, just written in 2 different forms, right? So you can see if I take the first one there, F equals P times 1 plus I to the power of T, if I take that formula there and divide across by this guy, the so-called accumulation function, if I divide both sides by that, I'll get F over 1 plus I to the power of T is equal to P, which is the second one on page 30. So it's the same formula written in 2 different ways, which is kind of unusual to give you the same formula in 2 different forms in your formula booklet. The reason it's in there really is to make it very clear to you that when you're doing a financial maths question, all I've got to get right is which of those 2 formulas I'm going to use to create my series. Right, so I'm going to pick one of these 2 formulas here to create my series. I'm then going to use that formula to create a geometric series and then add it up using one of the formulas from my formula book, which I'll remind you of now in a second. So that's the basic idea here. Now, in your head, the main mistake that students will make here is they'll pick the wrong formula. So let's just spend a moment just making it very clear how you pick the formula, because it's very, very simple. All right? That in your head, think about F for future. Okay, so it really means final value here, but think of the letter F means future, right? And think of P means past. Okay? And when you're trying to decide which formula you're going to use there, the question you're asking yourself is, when is the money being spent? Let me say that again. Okay, because if you get this right, the method's not going to vary from that point onwards. All you've got to decide when you're trying to choose which of these 2 formulas to work with is, when is the money being spent? Is it being spent in the future, or is it being spent in the past? Because there's only 2 types of question in financial maths, really. You're either saving money or you're borrowing it. right? So you're either saving money, putting money away every week to save up for something, or you're taking out a loan, you're borrowing it. So all financial maths questions are either savings or borrowings. And in both cases, what's going to happen is you're going to be making regular deposits into an account. So if you're saving, you're going to be putting money into your savings account at regular intervals, every week or every month, over a long period of time. If you take out a loan, you're going to be making repayments every week or every month over a long period of time. So in both cases, what you're going to end up doing is putting payments into a bank account at regular intervals. That's going to give you your series. But the question is, when is the money being spent? So suppose, for example, we do a savings question. Let's say you're going on holiday in a year's time. Maybe your 6th year holiday in 6 months' time. All right. So if you're saving up to do that, what you're going to do is you're going to put money into a bank account every week or every month for the next 6 months. And when is the money being spent? In the future, at the end of the 6 months to go on holiday. So when you're saving money, you're putting money away to do something with it in the future. So for that reason, it's the future value formula. It's that one there we use for any kind of savings question. No exceptions. Okay? Because in a savings question, you're going to be putting money in an account every single week or every month, and the money hasn't been spent. The money's going to be spent in the future. Okay? When that process is over. Okay? So think about your 6th year holiday. If you're putting money away every week or every month now, you're going to spend that money in the future. Any savings question is characterized by the fact that the money you're putting in the account every week or month is spent in the future. So we're going to use the future value formula to set up our series. Right? So it's this guy here, and you set up my series. What happens if you take out a loan? Suppose you don't bother saving for your 6th year holiday. You say, look, what I'll do in June is I'll take out a bank loan or a loan from my credit union. Right? So when you get the loan from your bank, you'll spend it to go on holiday. And then when you come back, you're going to start making regular repayments on that loan. So again, every week you're going to be making repayments on a loan. You're going to be putting money into the bank at regular intervals. But when is the money being spent? It's already gone. It was spent in the past. You spent the money before you start making those payments. So try to imagine, look, there's your weekly payments. There's a payment week 1, and there's week 2, and there's week 3, there's week 4, there's week 5, there's week 6. Okay, if you're saving, the money's going to be spent afterwards, in the future. Okay, when this process of putting money in your account every week is over. All right? In a loan, the money was taken out and spent there. So the money was spent before you start making these payments. Now you're paying it back. All right? So because in a loan question, the money has already been spent when you start making these regular payments. The money was spent in the past. It's this formula here we use to create our series. All right? So that's for all borrowing questions. And that's what it boils down to. So every question you do is going to be either a saving or a borrowing question. All right? So all you've got to do is pick which of these two formulas you're going to use to create a series. Once you make that decision, the method won't change beyond that point. Okay, it'll stay the same the whole way. And both these formulas are on page 30 of your formula booklet as I showed you. All right? And to decide in your own head which one is the one you should be using, just ask yourself, when is the money being spent? The money that's being put into an account every week or every month, when is that money being spent? In a savings question, it's going to be spent in the future, when that process of weekly depositing is over. In a loan, it was spent before that process of weekly depositing began, spent in the past. Okay, it's gone by the time you're making all those repayments. You're paying it back. Okay, so that's how you make the decision. I'll show you a couple of questions now to nail that down. But they're the two formulas on page 30, and that's how you choose which of those two formulas to use, right? So once you've made the decision, you're going to choose one of those two formulas and use that to create a series. And then in your formula booklet, okay, this time on page 22, so we go back to page 22 here, the sequence and series page. Okay, we'll then add the series up using this formula here. See it? So that formula there is for adding up the terms of a geometric sequence or series. It'll always be a geometric one in financial maths. So it's always that formula there you'll be using. Okay, and if you've done sequence and series, you'll be familiar with that one. If you haven't, don't worry, I'm going to show you how to use it now. But that's the formula you're going to use to add up the terms of your geometric series, right? So that essentially in a nutshell is what financial maths is for Leaving Cert. Okay, and you're going to be making a series of payments into a bank account at regular intervals every week or every month or every year. Okay, you're going to choose one of these two formulas here to make up a series to represent those payments, and then add up that series using the formula from page 22. So those two guys are on page 30 of your formula booklet, and the one for adding up the terms of a geometric series, this one here, is on page 22, right? Now, there's one other formula I'll just mention very briefly, and we'll get to it in a second. Okay, it's on page 31 of your formula booklet, right? So just to show you the final one, because I said it's a tale of 4 formulas, and there it is there. It's the amortization formula. Okay, and you can see here it is here on the very top of page 31. Now, it's probably just worth pointing out to you that the proof of the amortization formula is one of the 4 required proofs for paper 1. Okay, and that proof is on your notes for you. I've given you a copy of that proof on the last page of the notes. Okay, so that proof there, you should be able to prove that formula there, and I'll show you how we work with that one shortly. You will notice here it's for mortgages and loans. So this formula can only be used for borrowing questions, but I'll deal with that when we get to it. Okay, so that's fundamentally what we need to look at in financial maths. So it's a tale of 4 formulas. These 2 guys on page 30, one of which you will use to create a series. Okay, this guy from page 22, which you'll use then to add that series up. And there's one on page 31, the amortization formula, which will get me out of dark corners in some questions that we have a look at as we go along. Okay, so with all that in mind, let's get stuck in and have a look at the questions. Okay, so I'll start off with the question there on page 7, right? The first question there on page 7, question 1, right? So question 1 looks like this. You can see it says Annika deposits €1,750 in a savings account at the start of every year for 8 years, right? So it's for 8 years here. And money in the account earns it at a rate of 3.75% per annum. So per annum means per year, right? So it's the thing just to point out here with this question, all right, is you can see that she's saving every year for 8 years, and we're given a yearly interest rate. Okay, so that's all fine, right? So when you're using this formula here, okay, when we're using these 2 formulas here, okay, I represents the interest rate as a decimal, and it tells you that on page 30. Okay, so for example, it gives you the example there on page 30 that 7% interest is 0.07. Remember, to convert a percentage to a decimal, you divide by 100. So you're told on page 30 that in this formula here, I is the interest rate as a decimal, right? And t is the time. And these 2 have to match. So what I mean by that is, if that's the yearly interest rate, that has to be the time in years. If that's the time in months, then this would have to be the monthly interest rate. If that's the time in weeks, that would have to be the weekly interest rate. So in this case here, it's just worth pointing out here that she's saving every year, and we've got the yearly interest rate in the number of years, so we're okay. Okay, so we'll just get into the habit of checking that, all right? And it says that she puts money in the account at the start of every year. I'll show you now as we do the question the significance of that, okay? So if you think about this for a second, first of all, which formula am I using? Well, Annika's putting money into her account every year for 8 years. She's saving this money up. We don't know what she's going to do with it, but she's saving €1,750 every month, or say every year for 8 years. This is a savings question, so she's going to spend that money in the future. Sometime when these 8 years are over, she'll spend the money that she's saving right now. So because it's a savings question, the money is being spent in the future. So I'll use the future value formula to create my series. Okay, so that's the formula I'm choosing here. It'll always be that formula for any kind of savings question. No exceptions. It's always that formula there, right? So P is the sum of money, okay, that she's putting in her account. So the capital letter in the formula is the sum of money you're putting away every month. Okay, so it's the amount of each monthly payment is the capital letter there. I is interest rate and T is the time. So think of the money she puts in her account at the beginning of year 1. So she's going to be saving every year for 8 years. So just for the first question, let me just make that clear. Right, so there's year 1, 2, 3, 4, 5, 6, 7, 8. There's 8 years there. And here's where she's going to spend her money, right, at the end of the 8 years. Now, she's putting her money into the account at the beginning of each year, right? So the first amount of money, the first deposit she makes goes in there at the beginning of year 1. So how long will that be earning interest for? It'll be earning interest for all of year 1, 2, 3, 4, 5, 6, 7, 8. That's going to be there for the full 8 years, right? So that first payment will end up being worth this. It's 1,750, that's the amount of money she puts in, times 1 plus I. So remember, I is the interest rate as a decimal. So we're told the interest rate is 3.75%. divide that by 100, you get 0.0375. So remember, to convert a percentage to a decimal, you divide by 100. And then the time there is 8. So that's the yearly interest rate, that's the time in years, so they match, that's perfectly fine. That's what that first deposit will end up being worth at the end of the 8 years. Okay, so I could, if I want to put that into my calculator now, I can, okay, and find out how much that'll be worth 8 years from now, which is when she cashes out, okay, that's perfectly fine. But that's not the only payment she makes. She does the same at the start of the next year, right? So remember, the next year she's going to put, at the start of year 2, she's going to put another payment in, another 1750, right? So what's that going to end up being worth at the end of the saving period? Well, because that one went in a year later, it's only going to earn interest for 7 years, right? That's going to be in there for 1, 2, 3, 4, 5, 6, 7 years. So that second payment will be 1750 times 1 plus 0.0375 to the power of 7. That's going to earn interest for 7 years. And so on. This one will be, there's another payment goes in there. That'll be earning interest for 6 years, and so on. Right? So each payment is going to earn interest for 1 year less than the one before it because it went in 1 year later. Right? And so on. I don't need to write them all out. Just put the 3 dots, the ellipses in there to indicate that, that you've got terms there that you're not writing down. And just put the last one in. So remember, the last one goes in there at the start of year 8. The first one goes in the beginning of year 1. So the last one is in the beginning of year 8. We're told you say it at the start of each year, right? So the last one then will be 1750 times 1 plus 0.0375 to the power of 1. That last one goes in at the start of the final year, so earns it for just 1 year, right? So that's what the series looks like, okay? So this calculation here will tell you how much that first deposit ends up being worth at the end of the 8 years. That calculation will tell you what the second deposit ends up being worth at the end of the 8 years. The next one will be what the third one ends up being worth at the end of the 8 years, and so on. So I could, if I want to, write all of those 8 out, calculate each of them using my calculator, and then add them all together. But there's a shortcut, there's a quicker way of doing it, because that list there forms a geometric series. But that's how every question will begin, right? Choose your formula, pick the appropriate formula based on whether it's a saving or borrowings question, all right? And then write out a series like this. And now I'll show you the method I'm going to use now to finish this question. It will never vary from one question to another. How I add the series up will never change. Just show you the method I would always use here to add up the terms of the series, right? Now, suppose the question said that she saves at the end of every year instead of the start. What effect would that have on your calculation? Because you guys tend to get very bogged down in that. Okay, it's actually a very, very minor detail and has very little impact on your question. The examiner won't penalize it very much at all, maybe just a single mark if you get that wrong, okay? But if they were going in at the end of every year instead, right? You can see the first payment doesn't go in at the beginning of year 1, it goes in at the end of year 1. And that means that first payment misses out on the interest for the first year because it went to the end of the year, not the start, okay? So you can see that first one will only earn interest for 7 years, okay? And then the second payment will go in here and only earn interest for 6 years, and so on. And the reason why that doesn't happen is because, think about that last one then. The last payment goes in at the end of year 8, the day she's cashing out. So that there would be a power of 0. It earns no interest at all, right? Because it went in at the end of the last year, which is the day she cashes out. It's like you just put the money into your savings account and then take it straight back out again, okay? So it doesn't make sense to save at the end of each time period because you're losing out on a time period's worth of interest, okay? But that's what the effect it would be. If the examiner said she was saving at the end of every month, it doesn't make any sense, but maybe Annika's not that bright. All right, so maybe she is doing it that way. So if she's saving at the end of every year instead of the beginning of every year, the difference is the powers would go 7, 6, 5, 4, 3, 2, 1, 0, rather than 8 down to 1, right? So that's the only difference there. Don't get too bogged down in that. If you went from 0 down to from 7 down to 0 rather than 8 down to 1, all the numbers are the same. See, the 7 to 1 are all in there anyway. Just you won't have that when you have a 0 at the end. So your answer will be almost exactly the same. Okay, he'll just penalize your mark for getting the powers wrong. The other thing to point out is here that some people kind of say, well, in some questions that you see the powers going up. The powers go 1, 2, 3, 4, 5, 6, 7, 8 instead of 8 downwards. Couldn't matter less, right? If I put 1 here and then 2 here and then 3 here and so on, it's the same 8 numbers. They're just in a different order. And because I'm adding them up anyway, the total will be the same. So the order of the powers doesn't make a blind bit of difference. Don't get too bogged down in that and worried about that. That's not what you want to concern yourself with. These are the kind of little things that you guys get tied into a pretzel over, and they don't matter. All right? So the order of the powers, whether they go from 8 down to 1 or 1 up to 8, is completely irrelevant, because that's going to give you the same correct answer either way. No penalty. All right? The one that might cost you a mark is if you get the powers wrong. If you go, say, 0 to 7 rather than 1 to 8. Okay, that could cost you a mark, but again, it's not worth getting too bogged down in, because it's only a 1 mark penalty. It doesn't really affect your answer very much. All right, they're the key things. So once make sure you pick the right formula, and you've set the formula up this way. Outside of that, there's not an awful lot that can go wrong. I would always assume, for safety's sake, if you're not sure whether to go from 1 to 8 or 0 to 7, the one with the 0 doesn't really make sense. Mathematical sense, it's fine, but in real world sense, not really. Okay, so I would always, if you're kind of humming and hawing about it, you're not sure which one to go with the one where there's no power of 0. It's more likely to be the case. Okay, now I've deliberately laboured that a little bit there, because once you kind of get this idea here, once you spend a bit of time on the first question, all the other questions on the handout are pretty much fall into the same pattern. They all go the very same way, right? So here's my series written down. So now I'm going to add them up. And the sequence of steps I would follow here never varies. I like this method because it means I don't have to change my method at all, no matter what kind of question I'm doing. There's a few kind of variations of this question, but I don't have to change my method. So you might have been shown a slightly different way of doing this, which is perfectly fine. Here's what I would do every single time. So once I've written down my series, notice that that sum of money there is the same in every term. It's common to every term in that series. It has to be, right? Because the key thing here with a question of this type is that the person's putting the same amount of money into their account every week, or every month, or every year. If they vary the amount of money they put in every week, or every month, or every year, if these numbers were changing, then that's not a geometric series. And therefore, we can't add it up with our formula. So if that was the case, you would have no choice but to do that calculation, and then do this calculation, then do this one, and then do this one. So do the calculation separately for each year, and then add all your answers together. So there's only a shortcut here if the payment amount never changes. If the payment amount changes at all, then there's no shortcut. You'd have to do it by hand, working out each payment individually and adding them all together. So because the 1750 is common to every term, I can pull that outside a bracket like that. And then what am I left with inside the bracket? Well, the 1750's gone outside a bracket here. I'm left with that number there, which is 1.0375. That's just 1 plus 0.0375 to the power of 8. So that number there is this guy. So 1750's gone outside the bracket. I'm just left with this number here, which is that. This one, the 1750's gone outside a bracket. So I'm left with that number there, which is 1.0375 to the power of 7. Plus, I'd have 1.0375 to the power of 6, 1.0375 to the power of 5, and so on, all the way down to our last one, which is 1.0375 to the power of 1. Or if you like, just was it 1.0375 like that. So whatever your payment amount is, pull that outside a bracket first. Now, there's the geometric series I'm now going to add up using my formula, right? So your formula, as I mentioned to you a moment ago, it's in your formula booklet on page 22. It looks like that. Right, that's my formula. And notice for your formula there, you need values for A, or, and N. Very easy to pull out now. So again, if you've done sequence of series, that's fine. If you haven't, don't worry. Let me just show you how to grab those numbers here. All right. So A is just the first term in your series. That can just be the first number inside your bracket. So that's A there. Okay, so A just represents the first term in the series of numbers you're adding up. So that's just the first number inside the bracket. So that's my value for A. And then OR is the common ratio. It's the number I multiply each number in this series by to get the next one. Right? That's what OR is. Now, the simplest way to find OR is take any number and divide by the one before it. That's why when I'm writing out my series, I would always write down the first two terms, then the ellipse, and then the last one. It's just the first two and the last one is fine for me. I need the first two so I can find OR. Because now, so A, in this case, for this series, A is 1.03. You don't need to write this down, but just for my own benefit, is 1.0375 to the power of 8. It's the first term inside the bracket. And to find OR, divide this guy by that one. So take any number and divide by the one before it, right? So if I divide those numbers across, so OR then is 1.0375 to the power of 7 over 1.0375 to the power of 8. Okay? Now, when you're doing that, you can either do it by just cancelling here. So notice that you've got 7 1.0375s above the line and 8 of them below. So those 7 will cancel with 7 of those, leaving 1 below the line. So you get 1 over 1.0375. So you can cancel that by hand if you want to. It just saves you reaching for your calculator. If you don't want to do that, if you're not, don't trust yourself to do the cancelling correctly. If you put that into your calculator, 1.0375 to the power of 7, the second number, divided by the first one, your calculator will give you a whole number fraction, 80 over 83. That's perfectly fine as well. So you can either do that division there using your calculator, or you can do it by hand. I do it by hand because I don't want to break my flow. If I've got to stop every minute or two and reach my calculator here, it just slows my progress down. So I do that cancelling by hand. Say, look, there's 7 above, there's 8 below. So when I cancel, I'll have 1 left below the line. So I'll do that by hand. If you don't trust yourself doing that, then just use your calculator. It's 80 over 83. That's perfectly fine as well. All right, that's your value for OR. And N is the number of numbers in this list, which is the number of payments. So because it's every year for 8 years, N is equal to 8. Okay? So there's my 3 values. So I'll just drop those into my Sn formula now. So the Sn is the sum of those 8 numbers. It's A, which is this guy here. So it's 1.0375 to the power of 8. That's my value for A, the first number on my list, times 1 minus OR, which is 1 over 1.0375, to the power of N, which is the power of 8, like that, all over 1 minus OR. 1 minus 1 over 1.0375. So I'm just putting A, OR, and N into this formula here, and then just pop that into your calculator. Okay? So it's easy to identify A, OR, and N. A is whatever's first in the list of numbers inside the bracket. To find OR, take the second number divided by the first one, either by hand or by using your calculator. And then then N is the number of payments. The number of numbers listed is the same as the number of payments. Every year for 8 years, N is 8. And if I put that into my calculator, I get it's around about 9.4750 Now, I'm taking that whole number at this stage. I'm not going to round that off because I don't know how many of those decimal places I will need to give me my final answer. It doesn't matter if you don't write the entire number down there, but make sure you keep the whole number on your calculator display screen, right? I'll show you why now, because that's what these numbers in here, these 8 numbers in here, right, add up to that. That's that formula tell you what that list of numbers inside the bracket adds up to. So now, if that's what this list of numbers adds up to, if I multiply that number there, which is this total here, by whatever I pulled outside the bracket at the beginning, that'll give me the value of my savings, or the value of my loan, or the value of my mortgage, or my bond, whatever the question is. All I got to do now is when I've pulled out A, OR, and N from this sequence here and added them up, multiplying that number there by whatever you pulled outside the bracket at the beginning of the question will give you the value of the savings, or the loan, or the bond. So it's now 1750 multiplied by that number, divided by 9.4750. 25031 is equal to, use the answer button in your calculator, answer multiplied by 1750, and now round this to 2 decimal places. Remember, euro and cent, unless he tells you otherwise. Okay, that's why I wasn't sure how many of those decimal places I would need here to give me a number here that it's 2 decimal places. So it's 16581. So it's 16,581 euro and 29 cents. That's how much Annika will end up with at the end of this savings process. Now, I've deliberately spent a lot of time on that first question because everything we're going to do in the remaining questions is the very same. That method's not going to change. So all of our questions will be done the very same way now. Okay, so if you think you've got that, I said, really what you're going to see over the next kind of just the rest of the class here is just variations on that theme. There's 1 or 2 other little calculations we can tag on as well, which I'll show you. Because I'm going to cover everything he's ever examined or could examine in financial maths in this class. But fundamentally, that's what financial maths looks like for higher level Leaving Cert. Okay, so you're going to choose one of the 2 formulas, future or past value formula, to create a series, right? When you write down a series like this, you're going to add it up the same way. Pull the payment amount outside a bracket to give you a series of numbers inside the bracket. Identify A, the first number inside the bracket, the first term in your series. To find OR, divide the second one by the first one. To find the value of OR for any geometric series, take any number divided by the one before it, right? So divide this by this, either by hand or by using your calculator to find or, and n is the number of payments, which in this case is 8, every year for 8 years. Fill those three numbers into this formula here, which is on page 22 of your formula booklet, and when you found that number there, when you multiply that by whatever you pulled outside the bracket at the start of the question, you'll get the final value of the savings or the loan or the bond or the mortgage or the pension, whatever the hell. Okay, that's what financial maths looks like. Okay, so as we go along, if you have any questions, fire them into the chat. I'm happy to answer them for you, but we'll have a look at the next question. So here's question 2. Second question. Right, you can see there it says Blake lodges €300 into a savings account at the start of every month. Start of every month for 5 years. Money in the account earns it at an AER of 4.1%. Okay, so notice that the slight tweak in this one, right? So this time Blake is saving every month. Not every year, every month for 5 years, right? So you're going to be putting money into the account every month. Okay, in this case here, all right? And we're told that the AER annual equivalent rate is 4.1%. So at the moment they don't match, okay, that Blake is saving every month and we're given a yearly interest rate. So I'm not going to be able to use those same numbers in the formula. So you'll notice that he flags that for you in part 1. In part 1, he asks you to convert the monthly rate to the yearly rate, or the yearly rate to a monthly rate first. So in case you've missed that, you said the examiner asked you that, which he has always done in a Leaving Cert question. And mark that calculation part 1 as important, because I think there's only 1, maybe 2 past Leaving Cert questions where you haven't had to do that. In pretty much every Leaving Cert financial maths question, you will have to switch from a yearly rate to a monthly rate or vice versa. There's some kind of a change of time period in most Leaving Cert questions. So it's important you know how to do that. But just before we kind of do that one, just to clarify something there, that you'll see these abbreviations, these acronyms used in these questions, AER, APR, ANR. So the annual equivalent rate, the annual percentage rate, annual nominal rate. Okay, what's the difference between them? Nobody gives a shit. Nobody cares. Okay, from a maths perspective, we handle them the same way. All that matters to us from mathematically is that A means annual. All right, so when you see A, insert your favorite letter, or, that means it's a yearly rate, it's an annual rate. That's all that matters. So what's the difference between an AE or AP or AN or? I don't care. I'm not an economist, and there's a reason why that's true, so I really don't care. All right, all that matters to me is that the letter A is annual. These are all yearly rates. So there's a yearly rate of 4.1%. What's that as a month? You can't just divide the yearly rate by 12. If you do that, you'll get nothing. Okay, not only because you simplified the calculation, but it shows a lack of understanding of why that doesn't work. That doesn't work because of compounding, right? If you were dealing with simple interest, it means, look, you'll get 1/12 of 4.1% at the end of January. You'll get 1/12 of 4.1% at the end of February, and so on. It'll work out that way, just dividing by 12. But remember, when you're compounding, when you get your interest at the end of January, it's added on. And that's what you earn interest on at the end of February. Okay, so just dividing 4.1 by 12 doesn't allow for compounding, which will give you the wrong answer. Okay, so here's again the way we do that calculation, the way we do part 1. Okay, it's this calculation here, that 1 plus the monthly rate to the power of 12 is equal to 1 plus the yearly rate to the power of 1. So getting your yearly interest once a year is the same as getting your monthly interest 12 times a year. Or 1 plus the weekly rate to the power of 52. It's the same as getting your weekly interest 52 times a year, assuming there's exactly 52 weeks in the year, which a question would normally tell you if that was the case. All right, so I can use this switch between any time point at all. It's essentially just this part of the formula here, right? So if you look at that part of the formula, 1 plus I to the power of t, it's this bit here, right? So suppose you put, for example, €100 into your account, and you earn your yearly interest once a year, and you end up with a particular sum of money. For the monthly one to be equivalent, it would mean that if I put that same sum of money into my account at the beginning, and earn the monthly interest every month for 12 months, I'd have the same amount of money at the very end. That's what equivalent means. That the money I have at the beginning turns to the same amount at the end, no matter which way I get my interest. All right? That's why these two bits are not included in the calculation at all. They have to be the same. So the amount you put in the beginning of the year is the same, but getting your yearly interest just once a year, or getting your monthly interest 12 times a year, will result in the same final value. Okay, that's what makes them equivalent, and that's why those two bits aren't included in your calculation. Okay, but remember that we're dealing with the monthly rates as a decimal here. So the monthly one is what we don't know, so it's 1 plus I, to the power of 12, is equal to, we know what the yearly rate is. Okay, we're told it's 4.1%. So as a decimal, that's 0.041, because remember, it is that part of the present or future value form. It's that 1 plus I to the power of t bit. Okay, so it's this bit, the accumulation function bit here. It's that part of the formula we're using to do the calculation here. Okay, so I is the interest rate as a decimal and t is the time. So getting your monthly interest, 12 every month for 12 months, 12 times during the year, is the same as getting your yearly interest once during the year. Okay, and you can see that number there is just 1.041. Okay, so 1 plus 0.041 to the power of 1 is 1.041. That's just a number on the right-hand side. So now, to remove the power of 12 here, we'll go with the 12 through the power of 1/12. I'm going to use power of 1/12. Okay, because remember that rule of indices that tells you if you've got a number to one power and you raise that to another power, you just multiply the powers together, right? So if I've got something here to the power of 12, like that, if I raise that to the power of 1/12, when you multiply the powers together, 12 by 1/12 is 1. And x to the power of 1 is just x. So the power of 12 disappears, right? So to get rid of a power of 12, I'll go with power of 1/12. To get rid of the power of 3, I'll go with power of a third. To get rid of power of 2, I'll go with power of a half. Remember, power of a half is square root. We met that in the weekly grinds doing calculus. Okay, so to remove the power of 12, I'll go with power of 1/12 on both sides. So let's get 1 plus I is equal to 1.041 to the power of 1/12. Right? So I know that going a power of 1/12 on this side will remove that. I just go with power of 1/12 on this side here. And if you pop that number into your calculator, okay, I get like 1.00335. Now I'll show you why I'm taking to those many decimal places now. Right? So that's 1 plus I. Subtract 1 from both sides here. So if I subtract 1 here, I just get the I by itself. And then subtract 1 here, I get 0.00335, like that. And remember, that's not the monthly interest rate. That's the monthly interest rate as a decimal. Remember that the value of I in here is the monthly interest rate as a decimal. So you can see that's the yearly rate as a decimal divided by 100. So that's the monthly rate as a decimal divided by 100. So to turn that back into a percentage, multiply by 100. Okay, to turn a percentage into a decimal, you divide by 100. To turn the decimal back into a percentage, you multiply by 100. So if I multiply that by 100, it means the monthly rate is 0.335%, right? That's why I took it to those many decimal places. See what it said there? Give your answer to 3 significant figures. Okay, so what I needed there was, because I needed 3 significant figures, that's why I took those 3 numbers there. If you're not sure about that, just take this entire decimal answer here, subtract the 1, multiply by 100, and then round it off. But just make sure you've got the right number of decimal places when you get down the bottom here by reading the question carefully. So 3 significant figures, it's 0.335. Right? Now, if you divide 4.1 by 12, so if you just divided 4.1 by 12, you get 0.342. So if I did it the wrong way, by just dividing the yearly rate by 12, I get 0.342. It's pretty close. So compounding doesn't make a huge difference to the interest itself, but it's still wrong. And it will be marked completely wrong because you haven't shown you understand how the interest is applied. And also, you've massively simplified the question. It'll still give you a value you can work with the rest of the question. You won't lose any more marks, but it is wrong. So that's an important calculation. Make sure you know how to convert from a monthly rate to a yearly rate or vice versa. It's that calculation there, okay? And it's almost sure to be in a question if you get one, because he always throws that in, okay? So having done that then, look at part 2. It says, how many monthly deposits does Blake make altogether? Well, it's every month for 5 years. That's just 5 12s, which are 60. You're kind of saying, well, that's an insult, okay, to ask me a calculation that's straightforward. He's not asking you that because because he's checking you can do that. Why is he asking that? Why is part 2 there? He's putting that number 60 on your radar. He's getting you to realize, oh, hang on, we're not dealing with 5 payments here. Okay, so Blake is not making 5 payments into the savings account, and Blake is making 60 payments. All right, so he's putting that number on your radar. It's every month for 5 years. That means 60 payments at a rate of 0.335% per month. All right. So now maybe just take a second, just while I'm kind of getting it set up here, to see in part 3, can you now write the geometric series? So so like we did in part 1, now that I have everything right, can I now write my geometric series? What does my geometric series look like? Because once I do that, my method won't change. I'll just blitz the last part of the method very quickly. All right. So we're told that Blake lodges €300 at the start of every month for 5 years. Monthly earns an interest at a rate of 4.1% per annum. So we've already turned the yearly rate into a monthly one. So 4.1% per year is equivalent to 0.335% per month. 5 years is 60 monthly payments. So I can now set up my series, okay? So remember, again, because it's a savings question, Blake is putting this money into the account every single month and is going to spend that money at some point in the future. You're saving up money to do something with it in the future. So it's the future value formula I'll use. So it's this guy here. So let me just see what I've got. So P then, remember, is the amount of each payment. That's 300 times 1 plus I. Well, just think about that for a second. 1 plus I. So I can just go back and use that number there. See, 1 plus I is that, isn't it? No need to kind of write it as 0 to kind of turn that back into a decimal and then add it. There's my value for 1 plus I. You can write it down like that if you want to. Give you the same answer either way. So it's 1.00335 to the power of t. So the first one, remember, because it is the start of every month, that first payment will be earning interest for the full 60 months. So it's 60 like that. Now, I think with a bit of practice, you'd probably find, if I can get that first term right, Robert is officially your mother's brother. Right? I'll fly to the rest because it should be easy to set up the rest of the series then, and then I add them up the same way. So it's worth spending a couple of minutes in the exam getting that first term right. Because if I get that first term right, it means I've got the interest rate right, I've got the time period right, I've picked the right formula. If I get that right, there's not very much can go wrong beyond that. Because what's the next one then? Well, the following month, remember, it's going to be 300 times 1.00335 to the power of 59. That's one in a month later, so it's going to earn 1 month less interest, 59 months of interest, and so on, yada, 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 up to the last month, this one here, 1.00335 to the power of 1. That goes at the start of the final month and just earns the 1 month of interest. So because it's the start of every month, they go from 60 down to 1. If it was the end of every month, they go from 59 down to 0. Not a big mistake if you get those jumbled up, but the 0 doesn't really make sense. Okay, and if you went from 1 up to 60, perfect, right? And now we'll add them up the same way. So take the 300 outside a bracket like we did in the previous question, and when the 300's gone, and for this number here, which is 1.00335 to the power of 60, 300's gone, it's 1.00335 to the power of 59, and so on, down as far as that last one, which is 1.00335. Just make sure you don't lose a 0 there. When there's 2 zeros, it's very easy to miss one somewhere along the line. That's a big error. Well, I mean, it's not a big error mathematically, but in terms of your answer, it'll make a big impact. Okay, recessions happen when people lose zeros in financial maths calculations. Okay, but you won't be very heavily penalized. But just make sure you keep the 2 zeros, and then identify A, or, and N. So there's A there. That's my term. That's my value for A. To find or, divide that by that. So remember, or will look like that. It's going to be 1.00335 to the power of 59 over 1.00335 to the power of 60. Now I'm going to cancel that by hand and just get that. If you do that in your calculator, it'll probably decimalize it. You just check that. Okay, so 1.00335 to the power of 59 divided by 1.00335 to the power of 60. Yeah, that's about 0.996661185. Round that off any way you like. There's no penalty. Okay, so just round that off whatever way you like, okay, and use that value. So if you use your calculator, you will get a decimal value there. Approximate any way you like. There's no penalty. If the only difference between your answer and the examiner's answer is that you've rounded differently at some point during the calculation, there's no penalty for that. The only way you'll get the very same answer as your examiner on any Leaving Cert questions is if you've rounded the very same way he did at every step of the calculation. You don't have to do that. Okay, so if you round it differently, you get a slightly different answer. There's no penalty there. And N is 60. Remember, it's the number of payments every month for 60 months. All right, so the sum of those 60 numbers, it's A, which is this guy here, 1.00335 to the power of 60, times 1 minus, or whatever value for or you're using, like that, to the power of n, to the power of 60, all over 1 minus r. Okay, like that. See, I like this method, never changes, all right? And if I put that in my calculator, that comes out at like 66.55479.043. I'm not sure how many of those decimal places I need just yet, so I'll keep them for a moment. And then, as always, if I multiply that by whatever I pulled outside the bracket at the beginning, I've got the final value of the savings in this case. So 300 times that number there, 66.55479.043. And then I'll round that to 2 decimal places, and that comes out at 19,966 euro and 44 cents. Bosh. Okay, so yet again, same method, no difference. So question 3 then, okay, on page 10, the last savings question, it says Connor needs to have 2,500 euros saved in 18 months' time, okay? He decides to deposit the same amount into a savings account at the start of every week for 78 weeks, okay? And money in the account earned at an equivalent weekly rate of 0.1%. Okay, that's fine. So he's saving every week for 78 weeks, and we have the weekly rate of 0.1%, so that's fine. There's no problem there at all. So we've got the time in weeks and the weekly rate. That's perfectly okay. And it says use some of a geometric series to find the amount Connor needs to deposit every week to have the 2,500 saved at the end of that time. So how much does Connor need to put away every week to make that happen, right? So again, notice this is a savings question. And our method is the very same. Our method doesn't change. It's a savings question. So again, what formula am I using? Well, again, Connor's putting money into his account every week. When is he going to spend that money? In 18 months' time, when he saved the 2,500. Again, it's a savings question, so it's a future value question. Okay? So I'm going to use that form to create my series, right? So let me set my series up. So what does this here represent? This represents the amount of each payment. In the previous 2 questions, we knew what that was. Here I don't. I don't know how much he saves every month, but I know what it ends up having to be worth. So because I don't know what this is, let me just call this x, right? So it's x times. So what's 1 plus I? Well, 1 plus 0.1%, divide that by 100, it's 0.001, right? Remember, so divide a percentage by 100 to get a decimal. And that first one, it's every week for 78 weeks. So because he's saving at the start of every week, that first payment will be in there for a full 78 weeks, earning interest, okay? So he's going to earn interest there for 78 full weeks. There's my first term. And now I should be okay, shouldn't I? Second one is going to be x times 1 plus 0.001 to the power of 77. And so on. There's the last one, x times 1 plus 0.001 to the power of 1. There's my series. So the fact that in this question I don't know how much he's putting away every month, but I know how much he ends up with, doesn't change my method in the slightest. It's not a different type of question, very same method, right? So there's my series, just in this case, because I don't remember that the capital letter in this formula here is the amount of each payment. So if I know what that is, this will be a number here. If I don't, it'll be x. But now my method stays the same. X is common to every term there. Pull that outside a bracket. So pull your x outside a bracket like that, right? Then I've got this number here, which is 1.001 to the power of 78. The x has gone outside a bracket here, so I'm left with this number here, which is 1.001 to the power of 77, and so on. This guy here is just 1.001, like that. And add up the terms inside your bracket exactly the same way. Okay? Very same way we did previously, right? So again, there's my value for A, the first number inside the bracket. To find or, divide this by this. So I'm going to have the or is just 1 over 1.001. All right? If you're using your calculator to do that division, you'll get 1,000 over 1,001. That's fine. I'm okay with that. So remember, you can divide this by hand or by using your calculator. That's entirely up to you. And n is 78. It's the number of payments. Every week for 78 weeks. So the sum of those 78 payments then, it's A, which is 1.001 to the power of 78. That number there. Times 1 minus, there's my value for or. To the power of n, power of 78. All over 1 minus or, 1 minus this guy here. And if you add those numbers up, if you put that into your calculator, you get 81.16160432. Okay? That's what those numbers, so that's what that list of numbers inside the brackets here adds up to. They add up to that number there. And then remember, how do we finish the question? Multiplying this number here by whatever I pulled outside the bracket at the beginning will give me the final value of the savings, right? So remember, if I multiply this by x, so x times this, x times 81.16160432, okay? So multiplying those together will give me the final value of the savings. So in the previous question, we knew what this was, so multiplying those together gave me the final value of the savings. This question, don't I know what the final value is? I said, look, I know what that final value has to be. That final value has to be 2,500. So we know we need the final value to be 2,500. So what do I have to multiply this number by to give me 2,500? So you just divide across, divide 2,500 by this number here, all right? And you get that x, it's 2,500 divided by 81.16160432. Use your answer button there, and it comes out at like 32.05. No, 38, sorry, 30.80. Okay, so it's €30.80. So if he saves €30.80 every week for the next year and a half, he'll have his €2,500 raised. Now that's all the savings stuff. There's nothing more to it than that. Okay, that's essentially what the savings looks like. All right. So that's the savings. So what I'm going to do next then, as I'll show you, we'll have a quick look at the only other type of question, the borrowing ones. Okay, loan questions, and they are absolutely identical to the three we've just done. The only difference is I'll be using the other formula. That's all there is to financial math. So this method doesn't change here. The only variable is which of the two formulas I'm going to use here. These have all been savings questions. I'm using this one here because the money is spent in the future. We'll have a look at one now, at a couple of loan questions now, where the money is spent in the past. We'll just do a couple of borrowing questions. So we'll just take a little breather there for what, about 5 minutes, just to recharge our batteries before we get stuck in and do the borrowing questions. Okay. Right, guys, welcome back. So what we have a look at this time is we'll have a look now at working with loans. And I'll do question 4 now on page 12. And as you'll see, this question is line for line identical to question 1. The only difference is we're using the other formula, right? So see what the way this question reads, okay? It says David borrows a sum of money from his credit union. So he borrows the money this time, all right? He agrees to repay this loan in 24 equal monthly repayments of €161.83 at the end of every month for the next 2 years, and this is charged an equivalent rate of 0.85% per month. Perfect. So you can see again, there's no switching necessary here. He's paying every month for 24 months, and we've got the monthly interest rate here. There's no requirement I switch rates here. All right, so again, he will flag that for me if I had to, but he hasn't. So it says, use the sum of a geometric series to find the amount David originally borrowed. How much did he borrow? What was the value of his loan? The same we're finding the value of his savings, right? Now, remember this time, because the money, so David is going to be paying, again, like the previous way, he's going to be putting money into his account at regular intervals. Every month for 24 months, he's going to put money into an account here. But when is the money being spent? This time the money was spent already. He borrowed money from the bank, or the credit union, spent it on something, and now he's paying it back. So the money was spent in the past. So it's this formula I'm going to use this time, as I do for all borrowing questions. That's the only difference, right? So I'm using this one here, right? Now, just before we kind of have a look at this one here, suppose, for example, you took out a loan from your bank, and you said, right, I'm going to pay it back every year. I'm going to pay you €100, okay, every year for 3 years at 5% per annum, right? So let's say there's the 3 years there, right? There's year 1, year 2, and year 3. So here's the day you get your loan, okay? So when we're making repayments, doesn't it make sense here that repayments happen at the end of every time period, not the beginning? When we're saving, as we talked about before the break, you want to save at the beginning of each time period. If I save at the end of every month, it means I'm losing a month's interest each time. And it means the final payment doesn't get any interest at all. It goes into the account on the day that I'm cashing out. It doesn't make any sense to make repayments on a loan at the beginning of every month or every year. Why? Because it means the first repayment will be due at the beginning of year 1, the day you get your loan. So you'll be getting your loan and handing a chunk of it back the same day. So again, when you're saving, you should be saving at the beginning of every time period. That's what makes sense. That means we've no powers of 0. When you're repaying stuff, it should be at the end of every time period. Because again, that avoids 0. All right, so the key idea here is I'm going to make 3 payments here. Let's say, look, I'm going to make a €100 repayment here, a €100 repayment here, and a €100 repayment there. That's what I've agreed to do. I borrowed some money from the bank here, and I'm going to pay back €100 every year for the next 3 years, right? Think about that for a second. If I want to make a payment of €100 in a year's time, how much would I need to have in my bank account this morning, today? If I don't have to make the payment for a year, how much would I need to have in my account this morning? Well, I don't need the full €100, sure I don't, because it's got a full year to earn interest. So if I use that formula there to find out how much I need today, so let's say we've got 100 over 1 plus, the interest rate is 0.05, right? And that's just the power of 1. That comes out at like 95.24. So what that means is, if I have €95.24 in my bank account this morning, that will earn 5% interest over the next year, which will bring it up in value to 100, and I'll be able to make that first repayment. So if I've got 95.24 in my account today, I'll be able to make the payment that's due in a year's time, because it's got a full year to earn interest. What about that one there? Well, that one's got 2 full years to earn interest. So how much do I need to have in my account this morning to make that payment? Well, wouldn't that just be the 100 over 1 plus 0.05 to the power of 2? Because that one's got 2 years, and that's a little bit less. That's 90.70. Because that's got 2 years. So if I've got that much in my account this morning, 90.70, in the next 2 years, over the next 2 years, that will increase by 5% each year, which will bring that up to 100. I'll be able to make that payment there. And the same for the final one. We've got 100 over 1 plus 0.05. That's got 3 years to earn interest. So if I do that calculation there, the present value, the value today of that payment, okay, that's due in 3 years' time, is 86.38, right? So if I've got that much money in my account this morning, that'll allow me to make the payment that's due in 3 years' time. Because over the next 3 years, that will increase by 5% each year, which will bring it up in value to €100, and I have the money I need to make that payment, right? So if I've got this much money in my account this morning, I have everything I need to be able to make those 3 repayments of €100 over the next 3 years as and when they become due, right? So that's what your bank loans you. If you add those 3 together, you get 272.32. That's your loan. That's what the bank cuts you a check for. So when you borrow money from the bank, the check they give you is the present value on the day you draw the loan down of all the future payments you're going to make on that loan. In other words, if you take the loan they gave you and put it in your bank account, assuming your bank account earns the same amount of interest as you're being charged on the loan, you have exactly the right amount of money there to make all the payments you've agreed to make, the future repayments. Of course, you don't. You take out the loan, you buy something else, but you have to come up with that money yourself. But that's how loans are calculated. The loan you get is the present value on the day you draw the loan down of all the future payments you've agreed to make, right? That's why it's this formula here I'm using for a loan. Okay, because I want to work out what's the value on the day I get the loan of all the future payments I've agreed to make to repay it, okay? Because that's what my bank gives me a check for, all right? Now, of course, we don't do what I did here, decide what the repayments are and then work out the loan. You decide how much you want to borrow, and we'll do a calculation where you can find what these repayments are, but the principle's the same, okay? So that's the idea here. So that's the reason why we're using that particular formula, okay? And the beginning of every year is what makes sense. So I'll set my series up. Okay, so the repayment amount is 16183. So remember the capital letter sum of money, the amount of each repayment, 16183 over 1 plus I. And the interest rate is 0.85%, so it's 0.0085, like that, all right? And that first repayment is due 1 month after we get the loan. Okay, so when you get the loan today, your first repayment is due in 1 month's time because you repay at the end of each month. So it's due in 1 month's time. All right, it's the first repayment. And the second one then is going to be 16183 over 1 plus 0.0085. The second payment is due in 2 months' time, all the way up to the final payment is due in 24 months' time. So 1 plus 0.0085 power 24. So notice here that the powers here are going from 1 up to 24. In the previous questions before the break, they went from 60 down to 1. Doesn't matter. The order doesn't make any difference. If you go from 24 down to 1 here, it's the same 24 numbers. So when you add them, you get the same answer. There's no penalty there, that's fine. But why is it happening this time? Why are the powers going up this time and they went down the last time? Because when I'm writing my series, I always begin with the first payment. So the first number in my series is my first payment. Second number is my second payment, and so on, right? So if you're dealing with a savings question, say the powers went like that, 60, 59, 58, and so on. Why? Why are the powers going down when you're saving? Because the day when the money is spent is getting closer. So I'm saving every month. The day when I spend the money is 60 months away. Now it's 59 months away, 58 months away. So because the day when the money is getting spent is getting closer when you're saving, the powers go down. That's the way I set the question up. Here, in a loan question, isn't the day when the money was spent getting further away? I spent the money a month ago. I spent the money 2 months ago. I spent the money 24 months ago. So the day when the money spent is getting further away, that's why the powers go up. So the only reason the powers go down when savings and up when you're borrowing, the way I do the question, is because I just start with the first payment. But that doesn't matter in the least. If you just decide, look, I'll always do my series from 1 up to n, or from n down to 1, that doesn't matter. If you've got your series the other way around, you'll have a different value for A for me, but you'll have a different value for OR as well, which will compensate and give you the same correct answer. So if you go from 24, 23 down to 1 here, you'll get exactly the same answer I'm going to get in a moment, and there's no penalty. Okay? So just make sure we're clear on that. But now once I set my series up, autopilot. Take the payment amount outside a bracket, which we did in all the previous questions, 16183 like that. All right? Now, if I take the 16183 outside a bracket here, remember I've got a 1 above the line, and that's just 1.0085 below. So this number is left below the line, not above the line like it was the previous one. So it's 1 over 1.0085 plus, that's gone outside the bracket, so you've got a 1 above the line here, over 1.0085 to the power of 2, and so on, all the way up as far as 1 over 1.0085 to the power of 24. And now find A, or, and N, same way we did previously. add them up with your SN formula from page 22, and then multiplying that total by this here will give you the value of the loan. That is the same. Okay, so there's A. Divide that by that to find OR. And OR is also 1 over 1.0085. If you set the series up the way I'm doing it, where you always begin with the first term, your value for OR will always be 1 over 1 plus I. Same as it was in the previous question. It'll always be 1 over 1 plus I if you set them up the way I'm doing it here, where you always begin with the first term. But that doesn't matter. Remember, you can just use your calculator to divide that by that. And you'll probably get a decimal answer or a whole number fraction. Doesn't matter. That's perfectly okay. You do you. And N is 24, right? So the sum of those 24 numbers, it's A, which is 1 over 1.0085, times 1 minus, there's my value for OR, 1 over 1.0085, to the power of N, power of 24, OR over 1 minus OR. Right? And if I pop that into my calculator, that comes out at like, it's 21.6275, 648. Again, I'm not sure how many of those decimals I need just yet, so I won't bother rounding here. But I know if I multiply that number by whatever I pull out of the bracket at the beginning, that'll give me the value of my loan or my savings or my investment or my mortgage or my bond, whatever the hell the question deals with. So if I multiply the two of them together, 16183 multiplied by that, right? And that comes out at almost exactly 3,500. So that looks like the kind of sum of money somebody would borrow. Okay, so that's what David borrowed. He borrowed 3,500 euros. So what that means is if he's got 3,500 euros in his bank account this morning, he has exactly the right amount of money to be able to make a payment of 16183 every month for the next 24 months. That's what his bank is giving. But you can see the method doesn't change. Don't worry about the theory. The only difference between that question and question 1 was I used the other formula rather than the first one. Right? So look at question 5 then. Right, so on the next page. So let's have a look at question 5. So what do we got here? It says Emily takes out a mortgage of 486,500 euro from her bank to purchase a house. She agrees to make equal repayments at the end of every month. So it's at the end of every month for 35 years. And interest is charged at an AE or an annual equivalent rate of 3.65%. So see the way, again, in this question, which is very common for Leaving Cert, she's making repayments on every month, but we're given an annual rate here. So notice in part 1, he asked me to make the conversion, to switch from a monthly rate, from a yearly rate to a monthly one. Show that the monthly interest rate that's equivalent to an annual rate of 3.65% is about 0.3%. Okay, and then part 2, how many monthly repayments does Emily make altogether? So it's the same kind of two calculations there that we met previously. He's just putting those two on your radar. Okay, so part 1 then. So it'll be 1 plus the monthly rate. I'll just speed this one up just a little bit. To the power of 12 is 1 plus the yearly rate to the power of 1. And you'll see if you go to the past exam paper questions that are on the handout here for you, how often you have to do that switch. Just make sure you've got that in your toolkit to make a switch like this. So 1 plus the monthly rate is what we don't know. So 1 plus I to the power of 12 is equal to 1 plus the yearly rate is 3.65%. So that's 0.0365. Divide by 100 to get the yearly rate. And that's just the number 1.0365, right? And then as we did before the break in the first question, question number 2, to remove power of 12, we go with power of 1/12. So go with power of 1/12 over here. I'll just get rid of the power of 12. So we're going to power of 1/12 over here. So it's 1.0365 to the power of 1/12. And that comes out like 1.003. Or thereabouts. It's very close to 1.003, right? Subtract 1 from both sides, and we get that I is 0.003. And remember, that's the monthly rate as a decimal. To get a percent, you've got to multiply back by 100, because remember, you divide the yearly by 100 to get the decimal. So multiply the decimal by 100 to get the percentage. So that means the rate is 0.3% as required. Perfect. All right. And then part 2, how many monthly deposits does she make? Which is she says every month for 35 years. There's 35 by 12, which is 420. Again, he's just putting that number. So she's making 420 monthly repayments at a rate of 0.3% per month. Right? So part 3 then, set up your series. So it's the same question. So as I make my way slowly to the other board and clear it, just see if you can set up the series and make a start on that part. There's nothing different. Again, it's a borrowing question because when is the money being spent? When Emily's making these monthly repayments, the money has already been spent. She took out the money, she bought a house. The money's gone. The money was spent in the past. She's now paying it back. So it's the past value formula we're using. So I'll walk kind of slowly here. I'll give you a chance to see if you can set the series up. Because once you set the series up, you're on autopilot then. This is kind of our last series question. It's because we're nearly our last series, so it's we're almost there. So this is kind of our last series question. Okay. So this time, remember, we're going to use this formula again. That's the amount of each repayment. We don't know what that is. So like the one we had a moment earlier on with Connor, okay, we'll just call this x. So it's x over, and 1 plus I, remember, is that value 1.003. So 1.003 like that. And her first repayment is due 1 month after she gets her loan. She's paying at the end of every month. So that means that her first repayment is due 1 month after she gets her loan. So that's after 1 month. And the second payment then is going to be x over 1.003 squared, and so on, up as far as x over 1.003 to the power of 420. And now everything else is the same. Right? So we take the x outside the bracket, add up the terms inside the bracket with our MSN formula, and then multiply the two of them together. Right? So you can see if I take the x outside the bracket, this is just 1 over 1.003. So remember, when you pull the x in the bracket, you're after the 1 above the line here. So these numbers out here are below the line when you're dealing with the borrowing questions. Okay, they're not below the line in the savings ones, but because the accumulation function, this guy here is below the line in this formula. The numbers end up below the line when we pull the payment amount outside the bracket. Okay, so that's 1 over 1.003 squared. And it's 1 over 1.003 to the power of 420, reminding you, if you went from 420 down to 1, no penalty. Your value for A will be different, but so will your value for OR. So you'll get the very same value when you add these numbers up here and get the same answer. There's no penalty. So there's A. And if I divide that by that, I'll get OR is 1 over 1.003. If you divide this by this using your calculator, you'll get 1,000 over 1,003. That's fine. Same number, doesn't make any difference. Okay? If you had the sequence the other way around, that would be your first number there, and OR would just be 1.003. So your values for A and OR will both be different, so you get the same value. They can't compensate, and you get the same value for MS 420 now. Okay? So the sum of those 420 numbers, it's A 1.001 or 1.003 times 1 minus, there's my value for OR, to the power of 420, all over 1 minus OR. So with a bit of practice, it'll be like second nature to you now, all right? And if you pop that into your calculator there, you get 238.6034,774. So that's what those numbers, those 420 numbers inside the bracket, that's what they add up to. You can see this is where it's very helpful. I mean, if we're only making like 5 or 6 repayments, it wouldn't be impossible to do these individual calculations, or wouldn't that be doable? When you're dealing with 420 payments, we need a shortcut, and that's what this offers you here. So again, multiplying that number there by whatever you took outside the bracket at the beginning will give you the value of the loan, or the mortgage, or the savings, or the investment. So x times 238.6034,774 will give me the value of the mortgage, which we're told at the start of the question is 486,500. So we don't know what the monthly payments are. We know what it has to end up being worth. So again, to find x, divide this number here by that one. So 486,500 divided by that number there, it comes out at 2038.95. So that's monthly repayments of €2,038.95. So if you have any questions, I'll pop them in the chat, but that's there. There's your 4 variations. Okay, we did the present value formula where we know this number here and where it's an x. We've done the working backwards. So the loan version. where we know this number here, we got an x. You can see it's all the same method. Once I set my series up, I deal with it the very same way. The method doesn't change at all. Part 4 then says, find the total amount repaid by Emily over the lifetime of the mortgage. So remember, what has she done here? She's agreed to pay this much money here, so 2038.95 every month for 420 months. So if you multiply those together, that's how much she's going to pay back altogether. And that comes out at 856,359. So if you're wondering how banks make their money, look at that. Okay? Remember, she borrowed 486,500. But over the lifetime of the mortgage, you're going to pay back, what? Not that far short of double that. 856,359. That's because the length of the lifetime of the loan. All right? That's where the bank makes it. But the difference between the amount she borrowed and the amount she ends up paying back fully is the interest charged by and made by the bank. Okay, so that's all the geometric sequence and series part of financial maths, right? So that's really what financial maths is all about. Those kind of 5 questions there are the important stuff. Everything I'm going to show you now are just kind of little bits and pieces that he can tag on as well if he wants to, just other bits that he has asked in the past. But that's the bones of it there. Most of the Leaving Cert questions deal with that. Okay, so if you can do that, as I said, have a look at the past exam questions that are on the handout for you, and certainly try the practice questions on the handout for you. The solutions are for those there as well, and just make sure you've got this in your back pocket, making sure you can do that conversion at the top there. So the first kind of tweak on that then, if you look at question 6, this is much quicker. So the remaining questions are all quite short. There's not a lot to them. Okay, so question 6 then. So on page 15 it reads, Fahad borrows €5,400 from his bank and agrees to repay this amount in 5 equal repayments at the end of each year. So again, as usual, repayments, it's at the end of each year for the next 5 years at an annual rate of 9%. That's grand. So he's paying every year, yearly rate of 9%. So we don't need to make any switches here. Okay? So what the question says here is, using the amortization formula, or otherwise, find the amount of each of Fahad's yearly repayments. So as I said to you already, the amortization formula is that guy there. It's the one from page 31 of your formula, but top of page 31. It's the amortization formula, that one there, top of page 31, right? And that formula looks like this, right? So this one here, so A is equal to P times I by 1 plus I to the power of T over 1 plus I to the power of T minus 1. Now, this will allow me to work out, if when you're doing, say for example, the previous question, the Emily question there, okay? I could have done that calculation in one step using that formula there. P is the amount of money she borrowed altogether, 486,500. I is the 0.003, which we have here. T is 420. Put those numbers in there. You'd have got the 203,895 in one step. So if I can use this formula to find repayments in one go, why would I use sequence and series? So why don't I just use the amortization formula all the time? Remember, as I said to you, why financial maths is on the course in the first place. It's as a practical application of that geometric series formula, right? So really, the way he phrases questions, he wants to see that you can do that. Okay, in most Leaving Cert questions, he wants to see you doing that, right? So there are 2 circumstances. There are 2 things that would need to be true for me to do it the short way here. Okay, just to be clear on this. So when can I use my amortization formula? First of all, you can only use it for borrowing questions. It says it on page 31, it's for mortgages and loans. It can't be used for savings questions. So if it's any kind of savings question, you have no choice but to use the sequence and series. Okay, so this can only be used for borrowing. And secondly, if there's no mention of sequence and series. Now look at the phrasing of all the previous questions. It said use the sum of a geometric series. He's told me to create a series. Okay, so that's him telling you, I want to see you doing it the sequence and series way because that's what I'm testing. I'm testing your ability to work with a geometric series here. Okay, if he's testing something else, then he doesn't mind how you do it. So when he says use the amortization or otherwise, the or otherwise bit means I could use the geometric series method we've had a look at already. It'll give me the same answer. Okay, but in this case here, it's a borrowing question because Fahad has borrowed money and he hasn't told me I have to use sequence and series so I can use my formula, right? So to use the amortization formula, it must be a borrowing question and there must be no mention of sequence and series. If those 2 things are true, then use your formula. It's the quick and easy way of doing it, right? So in this case here, A is the amount of each repayment, and P is the amount you borrowed altogether. Okay, I and T are what they always were. Okay, so in this case here, to find A, we just say A is equal to, well, the amount he borrowed, P, is 5,400. Okay, so it's 5,400 is what he borrowed. Remember, I is the interest rate as a decimal, so 9% is 0.009. Sorry, 0.09, I should say. Divide 9 by 100. 1 plus I is 1 plus 0.09. To the power of T, it's every year for 5 years, so T is 5. Okay, then it's 1 plus I, 1 plus 0.09, to the power of 5, minus 1. So P is the amount he borrowed, 5,400. I is the interest rate as a decimal, as always. So 9% as a decimal is 0.09. And T is the time, which is 5. It's every year for 5 years. And if you just dump that into your calculator in one go there, you get 1338 30. Okay, now if you were to do it out the long-winded way, like exactly like the previous one, set up your series, yeah? So it'd be like x over 1.09 to the power of 1 plus x over 1.09 to the power of 2, and so on, up as far as x over 1.09 to the power of 5. Pull the x outside the bracket, add the numbers inside the bracket to see what that adds up to, and multiply that by x should equal 5,400. Divide across to find x, you will get exactly the same answer. That's the or otherwise bit. But because it's a borrowing question and he didn't tell me I had to use sequence of series, that's faster and I'm okay using that. So the amount of each repayment there is 1338.30. Now, look at the next part of the question. Okay. So look at part 2 then. Complete the repayment schedule shown below. Right? Now, he asked one of these, a repayment schedule back on the 2017 paper. Okay, so he asked one of these on the 2017 Leaving Cert paper 1, which is, I think it's on page 33 of your notes. The notes you have in front of you here, that question. So he has asked one of these before, all right, and it's not a difficult calculation, but just that the students struggle with it because I think a lot of students haven't been shown how to do it. All right, so your table looks like this. You can see the 4 columns here, the payment amount, the interest charged, the amount deducted from the balance, and the balance remaining, right? So you see that at the start of year the end of year 0, or sorry, let's just call it the beginning, here, the beginning of year 1, that's year 0 if you like. That's when Fahad gets his loan, so he now owes the bank 5,400, the amount he borrowed, right? So that's the number the amount he borrowed here. We now also know his payment amount, right? So we know that this payment amount down here is 1338.30. So this here is going to be 1338.30 every year. So to do a repayment schedule, you need those two numbers: how much he borrowed and then how much he paid, because this is not going to change. Okay. So let me just fill those in. Right. So the payment amount is the same every year. That's what you worked out previously. Okay? Now, let me just show you what this calculation is, because it's actually very simple. Okay? So see where you've got your 5,400 over here. I'll just even show you this for year 1, right? So the payment amount is 1338.30. So he currently owes the bank €5,400. At the end of year 1, he hands them €1,038.30. They don't deduct that from the balance, because then all he's doing is paying back that. He's not paying them any interest, right? So the bank is going to charge him interest here. So what the bank does, remember, he's being charged into the rate of 9%. So I said, look, at the moment, you owe us €5,400. We're going to get 9% of that, okay? So if I get 9% of that, that's the interest he's being charged, right? And 9% of 5,400 is €486. That's the interest there for year 1. It's 9% of what he still owes them. So what is it a bank or credit union? It doesn't really matter. It's a bank, okay? So what the bank says is, we're going to take your payment here and subtract our interest on it. So when you hand us 1338.30, we're going to take out €486 of that. That's our interest, and put that in our pocket. Whatever's left of your payment, we'll knock off your balance. So if I subtract this from 1338.30, I get 902.30, right? That's what's left of the payment I made when I subtract my interest. And that's what they knock off the balance. So subtract this from 5,400, all right? And we've got 4,497.70. And now you just rinse and repeat. So you can see it's just busy work now. All right, so it's the same with on the next year, right? So you can see 1,338.30 the year 2, 1,338.30 year 3, 1,338.30 year 4, and 1,338.30 year 5. All right, and just notice here in year 2, they say, right, you've made a payment of 1,338.30. We're going to get 9% of this because we're not going to give and charge that as interest again. You don't owe us 5,400 anymore. We'll get 9% of this now. So 9% of that number is your interest for year 2. And that's like 404.79. Right? So we're just going to charge you 9% of what you still owe us. That's our interest. We'll subtract that from your payment. So if I subtract that from the payment there, I get 983.51. And then we'll knock that off your balance. And so on, right? So your balance goes down to 3,514.19. All you got to do is complete that out. Now, I'll just kind of blitz this because it's really just this number down here is what I'm concerned with. All right, just to show you what this is all about. So now we get 9% of this guy here. Should be our interest in year 3. That's 316.28. Now take that away from our payment. It's 107.202. So that's what's left of this payment here when the bank takes away your interest, which is 9% of what you still owe them, right? And so if we knock that off the balance, we go down to 2,442.17. Right? Again, we'll charge you 9% of that in interest during the next year, which is 219.80. Subtract that from your payment, you get 116.850. Knock that out, take that off your balance, you get 1,273. Yeah, 1,273.67. Now, finally, if we charge you 9% of this in interest, right, we get 114.63. Right? Now, if I subtract that from the payment, I get 1,273.67, which is exactly the same as the balance. So when I subtract from the balance, you get a balance of 0. That's the idea of repayment schedule. It shows how making 5 payments of this amount here repays the loan that was taken out along with all the interest that was charged along the way, right? So this should be 0. Now, due to rounding, that might be 1 or 2 cents down here. You can still write that as 0 if you're going all the way to completion, all right? Now, the one in the 2017 paper, which is on the notes for you, it only does 3 years because it's just stupid doing it for 5 or 6. It's very repetitive. All you got to remember is what you're doing at each step, which is very, very basic. Okay, the payment amount, so to start your repayment schedule, you'll need to know the payment amount and the amount that was borrowed. So typically he'll give you one of those and you'll use the amortization form to find the other one. He'll either tell you how much he's paying back every time period and ask you to use the formula to work out how much he borrowed or vice versa. So using the formula, you'll have worked out one of these numbers here, you'll know the other one. So you'll know these numbers here and that one, and then that's just the sequence of steps there. Okay, whatever the interest rate is, get that percent of this number here, that's the interest you're being charged. Subtract that from the payment to see what's left, and what's left of the payment, knock that off the balance, and just keep repeating until you get down to the bottom of the table. Very, very basic, not too much to worry about there. But he did ask one back in 2017. I said it's on page 33. I just wanted to make sure I'd shown you one of those. And kind of the last new calculation then is question 7. Okay, so question 7 then. So here it is, page 16. So it says Gemma owes her credit card company. Ooh, easy, Gemma. Okay, 8,250 euro. Okay, so obviously ASOS had a sale or something and Gemma lost the run of herself, goes her credit card company 8,250 euro and agrees to a fixed monthly repayment of 300 euro until the debt is cleared. She's going to pay them 300 euro every month until she clears that debt. Okay, interest is charged at an equivalent monthly rate of 2%. Okay, so it's 2% per month is interest rate. How long will it take Gemma to fully pay off her debt? Right. So think about that for a second, right? So first of all, what I'm going to use here is I'm going to use the amortization formula. Why? What was the clue in here that I'm going to use the amortization formula? Well, first and foremost, isn't it, we're dealing with a debt here. She's repaying a debt. She's borrowed money from her credit card company to purchase 8,250 euros worth of shit, all right? And she has to pay it back now. So it's a borrowing question. She's borrowed money from her credit union, she's going to pay back. And I don't see any mention of sequence and series in there. So it's not like there's something mystical going on where I knew this was going to be an amortization formula. It's a borrowing question with no mention of sequence and series. So that's why I'm thinking of this guy here, right? And again, there's one of these. There's a calculation like this in that 2017 long question as well on page 33. There's one of them in the practice questions as well. So there's a few examples of this here, but just to make sure we're clear. So that's what made me think like this. Okay, it's a borrowing question, no mention of sequence series. Now let's have a look and see, what do I know? Well, A is the amount of each repayment. Do I know that? Yeah. We know she's paying back €300 every month. Okay, so we know what A is. Remember, A is the amount of each payment. P is the amount she has to pay back altogether. The amount borrowed. Do we know that? Yeah. That's 8,250. Okay. Do we know what I is? Well, I is the interest rate as a decimal. Yeah, the interest rate is 2%. As a decimal, that's 0.02. Okay, so it's 0.02 like that. 1 plus I is 1.02. Okay, do I know what T is? No. I know what T is. That's what I'm looking to find. Isn't it? T is the time it's going to take to pay it back. So that's going to stay as a T. Okay, 1.02 to the power of T minus 1. There we go. Now that's a big step forward in the question because I've kind of set up an equation, which a lot of people won't be able to do. But the key thing there is, that you certainly have seen one of these, so it's a bit more like you'll zone in on it. But what really pushed me in this direction was the fact that it's a borrowing question. There was no mention of sequence and series. Now, this looks like it's going to be epoxy difficult to solve. It's not. This is actually it's a lot easier to solve than it might look. All right? Then we've got an equation that contains a fraction here. So I multiply both sides by the denominator, 1.02 to the power of T minus 1. With that on both sides. So we multiply both sides by that common denominator. Okay? On the right-hand side, they'll cancel. Right? On the left-hand side, you can see I get 300 times 1.02 to the power of T. That's just 300 times 1.02 to the power of T. And 300 by minus 1 is minus 300. Right? These two guys are cancelled. So you can see I'm left with 8250 by 0.02 by this. So if you multiply 8250 by 0.02, okay, if I multiply those two together there, I get 165. So if I just multiply these two numbers together, because remember, this is all gone here, so it's just that by that by that. So multiplying these two numbers together here gives me 165. So it's 165 times 1.02 to the power of T. And if I get the 1.02 to the power of T's together on one side, number on the other, it's just a bog standard exponential equation to solve. Nothing new here. So I'm bringing this across here. I get 300 times 1.02 to the power of T minus 165 times 1.02 to the power of T. And with this minus 300 over onto the right, it becomes a plus 300 like that. And you can see these are like terms. It's like 300x minus 165x. So 300 minus 165 is 135. So I get 135 times 1.02 to the power of T is equal to 300. And there's a bog standard exponential equation to solve. We've dealt with that now in grinds already. We spent a lot of time looking at that in our Christmas revision courses. So dealing with these exponential equations we should be familiar with now. Remember, I'll divide across by that number first. And I get 1.02 to the power of T is equal to 300 over 135. No need to decimalize that now. And then how do I get rid of the 1.02 there? Remember, we're dealing with this, we've dealt with this a few times already. If you had that 2 to the power of x equals 32, to remove the 2 on the left-hand side, the opposite of 2 to the power of is log to the base 2, remember? So as long as those two numbers match, these two base numbers match, they will cancel, okay? So I go with whatever I do on the left, I got to do on the right. And log to the base 2 of 32 is 5. Your calculator will tell you that. Remember, that's how we solve an exponential equation. So to remove 1.02 to the power of, log to the base 1.02, right? So log to the base 1.02 like that, because these two base numbers match, they will cancel and leave the t behind. So whatever I do on the left, I got to do on the right. So I just put that into my calculator, log to the base 1.02 of 300 over 135, and that comes out around about 40.3. So you can see that means that 40 monthly payments is not enough. The number's bigger than 40, so we have to always round up that t is 41. It doesn't matter there that number there is less than 0.5. Remember, what that means is it'll take more than 40 months. which means it'll take 41 months. She mightn't have to pay a full €300 in month 41, but she'll have to pay a 41st monthly payment. So you always round that up. Okay, it just means that number is not enough, so we need the next one. So 41 months is how long it'll take her. The best part of 4 years. Well done, Gemma. That was a good blowout on the old credit card there. You'll be 4 years paying it off. I hope it was worth it. Okay, so those are the two little kind of unusual side calculations. The one where you find T from the amortization formula and a repayment schedule. Those we've just done there. There's examples of both of those in that 2017, which is a really good question, the 2017 long question. It's also the only one where he examined the proof of the amortization formula. So it's on the handout for you, right? So the last thing I'm going to look at then, just to bring us up to the end, I'm not going to do question 9 with you in class. It's on page 22, 23. That's just an income tax, a USC question. All right, just to remind you what's on the junior cert course. It is technically it's on the ordinary level course for Leaving Cert, and it's technically on the higher level course as well. It's worth just maybe having a look at that one, remind yourself how to do that. There's no value in me taking you through an income tax calculation here. Okay, it's not a good use of your time. But question 9 there shows you how to do USC, PRSI, and income tax. Just very quick, simple, working with percentages. I just cast my eye over that one because he did ask one of those. It's only worth 5 marks in 2024, right? But the last one I'm going to do with you today is question 8. It's a pension question. Now, he asked a pension question back in 2012, the first Project Maths, and hasn't asked one since. I don't really think he'll ask one again. It's a little bit much. I just want to show you one pension calculation just to be safe. And anyway, it's just a nice way of kind of revising, tying up with a nice festive bow what we've done over the entire class here, okay? And then we leave it at that, and once I've had a look at this question here, I will kind of obviously hang around, take any questions at the end if you're not sure. But we'll have a look at question 8 here, the last one, the pension question, right? So here's the question on page 18. It says, Harry is 30 years old, right? And he hopes to retire when he's 60. Yeah, good luck with that, Harry, all right? So he's hoping to retire when he's 60. He's not going to be retiring at 60, but he hopes to, okay, to retire when he's 60. He decides to start planning for his retirement. He wants to create a fund that will, from his retirement date, pay an annual pension of €22,000 at the start of every year for 20 years, right? Assume an annual rate of 3% in all your calculations, okay? It says we're asked to use the sum of a geometric series to find the size of the pension fund Harry will require, and then how we're going to save that, okay? So the basic idea with a pension calculation, if you think about that, so just in terms of Harry's setup here, right? So Harry's 30 at the moment, and he's going to retire when he's 60, right? So that means there's 30 years in here where he's working, okay? And he's going to be putting money into his pension fund the whole way along, right? So the key idea here is that when you're putting money into your pension fund, okay, think about that. If you're putting money into your pension fund every month while you're working, when is that money going to be spent? It's going to be spent in the future to fund your retirement. So that is, to all practical intents and purposes, like saving. So that's going to be done with this formula here. Okay? That's just like a savings question. So when you're looking at how Harry's going to save up for his pension, okay, for his retirement, I should say, that part's going to be done like a savings question. Okay, it's going to be very like the Connor question we did back in question 3, when we know how big a pension fund Harry needs, we can use the same method to work out how much he needs to put away every month to make that happen. So when you're working and putting money into your pension fund, okay, all those regular payments, you're dealing with a situation where the money's going to be spent in the future. So it's a savings question in every conceivable way, right? So then he retires at 60 and he wants his pension fund to pay out every year for the next 20 years, right? So from 60 up to 80 here, there's 20 years there. That's when his pension's going to pay out. Right? Now, essentially what that means there is that from 60 to 80, he wants his pension funds to give him 22 grand a year. All right? If he dies before he gets to 80, whatever money is left in his pension fund that he hasn't used yet just goes into his estate to be distributed to his next of kin according to his will. All right? So that money is kind of part of his estate he hasn't used yet. If he lives beyond 80, it just means he's not getting any money from his pension fund anymore. Okay, so he'll just have to rely on a state pension beyond that point there. So his pension will only fund the next 20 years of his retirement. He can choose that himself. You can choose, when you're designing your own pension, you can decide how many years you want it to provide you with money for and how much you want every year. Just if you kind of say, look, I want it to provide for 40 years, 60 grand a year, that's going to mean you're going to need a huge pension fund here, which means you have to be putting a load of money away every month. So again, there's a balancing act there. How big a pension fund do I realistically need, and can I afford to put away? And then what kind of retirement will that give me beyond that point? Okay, but that's the idea here. So if he dies before he gets to 80, whatever's left in his pension fund that hasn't been drawn down yet will go into his estate. If he lives beyond 80, he'll be relying on a state pension. He won't be having his own private pension, won't be paying any money beyond that point, right? But the key thing here is that this part here uses the other formula. Because what you think about, remember, that's the present value. And his pension fund essentially is the present value on the day he retires of all the future payments his pension fund's going to make to him. So if his pension fund's going to pay him 22 grand a year for every year for the next 20 years, all the money necessary to make those payments has to be in his pension fund at the day he retires, because he's not going to have any more income to keep contributing to that. Okay, so again, 22 by 20, I don't need kind of the 440,000 euro in there. So I don't need to multiply like 22,000 by 20 and say, look, I need that full 440,000 euro in my pension fund the day I retire, because remember, it's going to earn interest as time goes on. So that's how we're going to be using this formula here. So that's the key idea with a pension fund. Okay, with a pension calculation. You're going to use this formula here to work out how big a pension fund he needs, and use this formula here then to work out how he's going to save that. So if you look at the kind of the calculations, we have them here then. So part one, he says that, look, Harry retires when he's 60. He wants his pension fund to provide him with 22 grand a year at the start of every year for 20 years. Okay, so how big a pension fund does he need, right? So we're going to use the present value formula. So say, for example, look at the first payment. So there's our present value formula. Okay, so how much does he need to make that first payment? Well, remember the sum of money is 22,000 euro. 1 plus I, well, I is, the interest rate is a decimal, so it's 3%. As a decimal, that's 0.03. And just be careful here. When is that first payment due from his pension fund? Immediately. It says from the date of his retirement at the start of every year. So this is unusual because that's a zero, isn't it? Think about why that's a zero. Because remember, so Harry is 60, he's just retired today, right? So he no longer has an income. So if he doesn't get his first pension until the end of year one, what does he live on for the first year of his retirement? He's got no income there. I mean, I suppose he could set up an OnlyFans, but he's 60. Okay, that's a niche market I've ever heard. Well, let's not go down that route, all right? So he says, look, it's probably better for all concerned if I just get my pension fund to pay the first pension at the beginning of year one. So the first repayment is due in 0 years' time. It's due immediately to fund the first year of his retirement. Now, it would be very easy to miss that and go from 1 to 20 with the powers. Not a big mistake, but that's kind of the one place where a zero makes sense, right? That's his first payment. And then there's the second payment, 22,000, 1 plus 0.03. That second payment is due in 1 year's time, 1 year after he retires, to fund the second year of retirement, and so on, up to the last one, like that. That's 1 plus 0.03. And remember, that's going to be due at the start of year 20, which is 19 years from now. So the powers go from 0 to 19, not from 1 to 20. I've mentioned that already. If you missed that and went from 1 to 20, it's not a big mistake. It's not going to make a huge difference the rest of your calculations, and you won't lose any marks in parts 2, 3, or 4. But that's why there's a zero there. The first payment's due on the day he retires, in 0 years' time, on the day he retires. So now, the rest of the method is the same. Let's pull the 22,000 outside a bracket. Okay, now remember, 1.03 to the power of 0. N to the power of 0 is just 1. So that's just 1 over 1, which is just the number 1 here, right? Okay, so this is going to be a number 1. N to the power of 0 is 1, so it's 1 over 1, which is 1, when I pull the 22,000 outside a bracket, plus a 1 over 1.03, because that 20,000 has gone outside a bracket. We're left with that, plus blah, 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 all the way up to 1 over 1.03 to the power of 19. And now, everything's the same as we've been doing all night, okay? There's A. Obviously, if you divide that by that, n divided by 1 is the same, so R is just 1 over 1.03. And n is 20, don't mind the powers. It's the number of payments. Every year for 20 years is 20 payments. So the sum of those 20 payments, it's A, which is 1, times 1 minus, there's my value for R, to the power of n, to the power of 20, all over 1 minus 1 over 1.03, okay? And that comes out at, those 20 numbers add up to 15.32379911. And as usual, multiply that by the number I pulled outside the bracket at the very beginning. I'll find the value of his pension fund, the value of the pension fund he needs. Okay, 15.32379911. And that comes out at 337,123.58, right? So remember, he's actually going to end up drawing down 440,000 altogether. Multiply 22,000 by 20, so 22,000 a year, every year for 20 years, is 440,000 euro he's going to actually take out of his pension fund over the course of his retirement. But he doesn't need to have that full 440,000 in his account on the day he retires, because it's going to earn interest. If he has that much in his account, that is enough to make sure he can fund those 20 payments of 22 grand a year. Okay, so that's the size of his pension fund. That's what he needs, right? So in Harry's case, that's what he has here. So he needs, well, at the day he turns 60, he needs to have 58, in his account. So parts 2, 3, and 4 are now just the savings question like we had with Connor. Okay, so if you've got 30 years to save that much money, how much you need to save every month? It's just another savings question now, no different than the previous one. You can see in part 2, it says find the monthly rate. So if it's okay with you, I won't kind of go through that in detail. It'll just be that one again, just 1 plus the monthly rate to the power 12 equals 1 plus the yearly rate to the power of 1, all right? So that'll just be 1 plus I to the power 12 equals 1 plus 0.03. Remember the 3% there is a decimal to the power of 1. If you work that out, I think you get the rate there ends up being, it's 0.25%. You can kind of finish that calculation. The solution is given to you anyway. We've done a few of those tonight. It's always going to be in there. So getting 3% per year is the same as 0.25% per month. It says, in order to create this pension fund, Harry intends to deposit the same fixed amount into the fund at the start of every month from now into retirement. So at the start of every month, that makes sense. He's saving now. Start of every month makes sense. How many monthly deposits will he make? Well, he's 30 now. He's retiring at 60. That's 30 years multiplied by 12. So 30 by 12 is 360. And now we can set up our series, right? So again, this time, because the savings question, we'll use this formula here. So P times 1 plus I to the power of T. So we don't know how much the savings amount is every month. That's what we're trying to find out. So it's going to be X times 1 plus I is 1 plus 0. That's 1.0025. And the first payment will be in his account for the full 360 months to retirement, because it's going at the start of the month, and so on. X times 1.0025 to the power of 359, yada, yada, yada. X times 1.0025 to the power of 1. And now finish the question the same way. Pull the X outside a bracket, right? And you get that 1.0025 to the 360, 1.0025 to the power of 359, so on, 1.0025 like that. There's A. Divide that by that to find OR, and OR for me just ends up being 1 over 1.0025. N is 360. Have you put those numbers into your calculator? Okay, the value I got when I added up those 360 numbers was 584.1937268. So that's what the list of numbers in here adds up to. So multiplying that by X, remember, should give us the value of the pension fund he saves up. And we need that to equal this value here, the pension fund you worked out previously, because that's how much he needs to have in his fund for the lifestyle he's looking for after retirement. So that has to equal the 337,123.58. So divide across by this number, and X ends up being 57707. So €577.07 a month. Every month until retirement will give him a pension fund of that amount there on the day he retires. And if he's got that much as pension fund the day he retires, he'll be able to draw down 22,000 a year at the start of every year until he's 80. That's the pension. So you can see it's a nice way just to recap on the two of them there. You've got the savings and the borrowing style question. You've got the one where you've got an X here, and where you've got a number here, and you've got the switch of interest rates in the middle, right? So there is a pension question. There's the 2012 exam questions on the notes for you. Okay, that's there for practice. And so there's also a pension question in the practice ones I've given you as well. So I like the two pension questions, not because I think they're likely. I'm not sure he'll ever ask one again, but it's a good way of nailing down the important bits and pieces in financial maths. Okay, so that's all the financial maths then. That's all there is to it. And all the exam questions are there, as I said. You can have a go at those along with the practice questions. So if you have any other questions, feel free to pop them in the chat. I'll be around in the chat for another little bit of time yet. Okay, and other than that, I'll see you soon.